Alright, what's up guys? So today we're going to be looking at homework number 10, and that's writing the method is prime. So it takes in an integer input parameter, returns a boolean that tells whether or not the number is prime. So obviously true if it's prime, false if it is not prime. He gives you the header, Dr. Neat gives you the header to start with, and in my class, in my period, we talked about all three versions of making a method. We talked about like void no parameter, we talked about void parameter, and we talked about return methods. So we're going to be looking at the most complicated of the three with return values this time and a parameter. So if you haven't seen that before, definitely stick around, watch this video, because that's going to help you out with that skill. And then we have a sample output down here for checking if 1000 is prime or not. So I actually have two methods of solving this to show you guys. So for most of the other homeworks, I did them last year, and so Dr. Neat has already seen them from me last year and graded them and said, hey, this is good. And so I haven't been really sending in my answers because he saw them last year. And, you know, he tells me, and he tells you guys if your solution isn't quite what he's looking for, so I'm worried about it. But this time, we actually didn't have this homework assignment last year, so I went ahead and sent him my response, and I was like, hey, what do you think? And he was like, you know, this is good, but why didn't you do it this way, which is simpler? And I said, well, I don't really know. So I'm going to show you what he came up with first, because it is simpler, and that objectively makes it better in terms of runtime and data storage and all that. And then I'm going to show you my way, because my way features some stuff that will be on the AP test, and that, well, I learned it second semester because last year was weird. If you guys want, starting with this video, you can start kind of learning it now. But we'll start with the simpler method. So we have the header that he gave us. And then we have if a is 1, and then we talked about and. We talked about the two ampersands, but this means or. So if either one of these is true, then we're going to go inside the if statement, even if one of them is not. So if it's not 1, but it is 0, we're going to go in there, even though they're not both true. So this is or. And then so because 1 and 0 are kind of weird when it comes to like dividing stuff by them, right? And then 1 is like not really considered prime, it's not really composite. And then like I said, you know, we had the divide by 0 error. I went ahead and was like, we'll just, you know, they're not really considered prime, so we'll just, if it's either one of those, we're just going to return false immediately. And then the nice thing about return statements is that as soon as you reach a line that says return something, it doesn't run the rest of this. It's done. It's like putting break in a while loop. It says, okay, we're finished. We have a value that you want me to return. We're not going to run the rest of this. We're not going to check anything else. So once it sees it's 1, once it sees it's 0, then we're good to go. Hopefully you can't hear that, but if you can, that's my printer. And then we go into this for loop. We have b is 2, because we don't want to start at 0, because again, we're kind of doing, we're doing modulo here, which is like division. You can't really divide by 0. And then we don't want to start at 1, because if you modulo by 1, you're going to get 0 every single time, which again, we don't want. So we're going to start at 2, and then we're going to go from 2 all the way to a, whatever you put in there. And then obviously we're going to add 1. So if a modulo b equals 0, and so what this means is if we divide a by b and there's no remainder, right, which means we got whole numbers, which means the number can't be prime, because if it was prime, the only factors it has are 1, which we've excluded, and itself, which we don't go to a, we say less than a, so we go to the one before a and stop. So then a modulo b, if we don't get any remainder, then it has to be composite, and so then we return false again. And then if we go through all of this and we don't go in this if statement and we never go in this if statement, get all the way to the bottom, we return true, because then it has to be prime. So I put some examples up here, and so for you guys, he wants you to have it like write a sentence. But at this point, I'm fairly confident in your ability to come up with a system.out.print. So I went ahead and just tested my method. So we're going to test 0, because that's kind of weird. 169, because that's weird, because it's the square root. It's 13 squared. So its only factors are 1, 169, and 13 and 13. And then 27 is also just a pretty normal composite number, and 11 we know is prime. So this is kind of, Dr. Neat always used to tell me, try to break it, and so we're going to try to break it with 0 and make sure that this part works. 169, because again, its factors are kind of weird. 27 is a pretty normal input to put in, and then 11 we know for a fact is prime. So I'm going to go ahead and test it with those values, and I'm in the correct folder, so we're going to compile it, and we're going to run it, and we get false, which we want. Oops, let me minimize this one moment. Okay. False, which we want, false, which we want, false, and true. Alright, looks good. So that's the simplest way that I've gotten from talking to some of the kids in my period. I think this is the simplest way that I've heard. And then, so we're going to take a look at my way now. My way is a little more complicated, but it also works. And this is what I mean when I've been telling you guys, like, if you come up with something besides my solution, but you've tested it a lot and you know that it works for all cases, then congratulations, you solved the homework. Even if it's a little more complicated, or even if it's a little bit, like, kind of off the walls or whatever, like, hey, that's totally legit. You solved the homework, no problem. So, we're going to take a look at mine. And the first thing I want you guys to notice is that all the way up here, we have import PKG, input array list, which you guys don't know what that is yet, but that's a class that you're going to use second semester. And then I added this line, import java.lang.math, and so that imports the math class. And so some of you, I know at least in my period, have gotten far enough where you replace canvas.rand with a method called math.random. And then there are other methods that math.rand has, like it has square root and power and stuff like that. So it's for doing math, as the name suggests. So my method for doing this involves that. And some of this math.random especially is on the AP test. So if you haven't seen this before, this is your chance to kind of start getting familiar with it. But also, if you haven't seen it before, don't worry, because we will teach it to you formally eventually. So again, we have the same for testing. And then we're going to go down and actually look at the method. So we have the same header, and then the same first if statement. And then after that, this is when it gets a little different. So we start with 2 again for the same reasons, but this time I only went to 10. So my thought process was, or I went to 9. So I did digits 2 through 9. So my thought process was almost every factor that every number could have, it has factors like, even if you have a number that like its factors are greater than 10, most of like its factors, if that makes sense. So like if you have a number that's one of its factors is 15, 15's factors are 3 and 5. So then that means that the number that has a factor of 15 must also be divisible by 3 and 5. So I figured this will catch just about everything. And then so I pulled up an image, and I have one here that's kind of similar, of like prime numbers. So all the highlighted ones are prime, right? And so I was looking at it and I'm like, yeah, this will work. But I realized that I had numbers like, there are numbers like 169, where it's the square of a prime number. So 13 squared, 13 is a prime number. But that's 169, those are its only factors, that none of its factors can be divided into anything smaller. And so I kept looking at prime numbers, so I'm like, yeah, so the squares of prime numbers are the only things where this fails, so I have to come up with something to solve that. Again, Dr. Neat's method is much simpler than this. I just want to show you guys what I figured out for the math class. So I did some experimentation with math.square root, which this, as it looks like squirt, but it stands for square root. So it does square root of whatever you put in there. And interestingly enough, I experimented with it a little bit. If you put it in integer, it gives you a double. If you put in a double, it gives you a double. So also some casting in there. Like if you put in like 4, and then it'll give you 2.0. And then, so for this, what I did, my if statement here says math.square root of a, so we just take the square root. If it doesn't equal math.square root of a modulo 10. And so for this, it's a little weird, and I took some experimentation to figure it out. But basically, what that does is it looks at like the integer portion of the answer. And so if you have a number that doesn't get square rooted evenly, so like 169, when we do this returns 13.00, right? And then this returns, I think it returns 1, or no, it returns 3. I don't know. I can't do modulo in my head, guys. I'm sorry. But yeah, it doesn't return 13, right? Because we get 13 from this, and then we modulo that by 10. Yeah, so it returns 3. It returns 3. And then, so these, they're not the same, so that means we're going to return false. But if we take like, let's see, how about 17, right? So that's a prime number, and it's not the square root of anything else either. So if we do square root of 17 is, I have my calculator right here, hold up. Square root of 17, it's like 4.123, goes on, you know how square roots are if they're not perfect squares. It's a mess. And then this also returns 4.123. It just doesn't evaluate to anything else because it only looks at the integer part. It only looks at the 4. So if you moduli that by 10, then it still gives you the same thing. So that's why I figured out that this works. This also returns false. And then if it's like a square root thing, and if it's the square of prime number, and then if we get through all of this, then we're going to go ahead and return true. So let me compile and run this, and I'll show you we should get false, 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 true again. Oops, come on. Thank you. False, 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 true. So there we go. There you have it. There's my way. It's a little more complicated. We looked at doubles versus ints and math of square root. So this took a lot of experimentation on my part, and because I was looking for a way to tell whether or not like it was a perfect square, and I wasn't sure how to do that, and this is what I came up with, and it works as far as I know. So there you go. Yeah. Hopefully that taught you something new, and hopefully it helped. The other simpler one showed you how to do this homework really easily, and maybe you thought this was interesting too. So yeah, there you go. Leave any questions, comments, concerns. Maybe you guys found an even simpler way to do this. If you have less than, what is this, like 10 lines of code? 11 lines of code? If you have less than 11 lines of code, you know, hit me up, let me know. I'd love to see simpler ways to do this. But besides that, I will see you all next week. Thank you.